So I am standing in for Thomas Rivera, who was not able to travel. Thomas and I worked together on a bunch of zero trust kind of activities in the past. He is the chair of the IEEE's Zero Trust Security Working Group, which is a sister organization to the Security and Storage Work Group, and is involved in different aspects of cybersecurity. So he and I, our paths cross almost continuously. Okay, so this is a talk on zero trust, or bust, as we say. How many of you have heard of zero trust? Is this something you're okay? A few. It's definitely a U.S. government-centric kind of activity, but that tends to have a ripple effect over time. Okay, legal notice. I'm not a lawyer. I play the part of a lawyer. I'm not your consultant. He pays your money, takes your chances. You own all the risk. That's my version. Okay, so zero trust, what is it? It's a collection of security methodologies that work together to enforce access with the view that your network has already been compromised, using contextual information from identity, security, IT infrastructure, risk and analytic tools, enabling dynamic, continuous, granular enforcement of security policies. What the heck does that mean, right? So basically, you assume from whatever perspective you're going to take, we don't trust anything. We assume it's been compromised. And this is an interesting starting point because this is not the model that security has historically taken. And if you're starting from a data center perspective, then obviously everything out of the data center is not trusted. But what we're seeing, at least from how the US government is dealing with zero trust, it's more of looking, for example, at the server level, or maybe at a solution level. So maybe your email solution, anything outside of that is not trusted. Or individual components like the servers in your email solution, if you kind of go down to that level, it doesn't necessarily trust anything else. So when we say isn't trusted, there's no implicit. Everything has to be explicit trust relations being established. And you assume worst case kind of scenarios, all right? So this is a pretty big change in, you're not talking about things like firewalls and VPNs, intrusion detection systems and intrusion other kinds of common technologies, because those assume a boundary, and inside it's free love computing, and outside that's the bad environment. So there's not really inside outside. It's me and you're bad is kind of how zero trust approaches this. Okay, so the history, this is going to drive me crazy. This has been around for a while. So the Jericho Forum, dealt with outside is the new inside kind of thing. So this is, we were starting to see signs of, the firewalls are really, there's not a perimeter, or if you want, it's so full of holes, it really isn't a perimeter, right? And then we saw Forrester started talking about zero trust research, and the Forrester Wave Zero Trust Extended, Google Beyond Corp, Gartner's 2017 Carta Framework. So there's been, as you can see, lots of hints at this sort of showing up over time. So there's some characteristics that typically fall in the zero trust arena. So you need a consistent security strategy for how users access data, wherever it is, whatever form it's in. So and this is kind of a subtle point, but we've often seen from a security perspective, the user accessing email versus accessing a database versus accessing something else. The authentication, authorization, access controls for each one of those may be completely localized. There's no consistency across those different solutions, if you will. In the case of Zero Trust, you're really trying to make sure that when Billy Bob Joe is in doing what he's doing, or Sally Jane is doing what she's doing across the infrastructure, that's understood and the appropriate protections are in place at all times. Might even be considering where they're coming from, what time of day, what time of year in these kind of ecosystems, right? Assumes a never trust, always verify stance. So this is kind of where the zero trust labeling comes from. And this applies to all data access and all resource utilization. So you want to use a printer, you're going to have to basically authenticate. We're seeing instances for certain government entities that the authentication process can be quite onerous. Almost everything you try to use, you gotta authenticate again, or you gotta use some sort of multi-factor authentication for it's like every transaction you do. So we're seeing in the government setting, they're trying to figure out what's the right balance on this, but it's back to sort of this comment. There's this continuous authorization, and this is a real-time kind of authorization. So it's not like you logged into a system and at the point that you logged in, you're granted certain permissions. This is every time a transaction, every time you attempt to do something, what's your authorization at that moment? Because somebody may have said, no, he's no longer allowed to do this. And that needs to be reflected near instantaneously. Definitely increased visibility and analytics across the enterprise. So you want to be able to know at any given point in time who's doing what, when, how, where, and why. And from a zero trust perspective, there's a lot of monitoring. There's a lot of policy enforcement kinds of things that come into play. Okay, so zero trust has certain assertions. The network is always assumed to be hostile. Well, I mean, the security world, we kind of believe that, but what this means in your office, you got 3 systems running. From a zero trust perspective, you assume that the network between those 3 laptops is hostile, that one of the other laptops may be attacking the other one. So if you make that kind of assumption, what kind of protections would you put in place? So it's no longer thinking about, well, it's in a subdomain and I don't have to worry about that. No, this is, so certain kind of sharing services probably aren't going to be turned on in a zero trust kind of setting. External, internal threats exist at all times. So there's no, safe time or maybe less threatening. Network locality, definitely not sufficient for deciding trust. So I'm in the office, big deal. It has no relevance to a zero trust kind of scenario. Every device, user, network, application, and data flow is authenticated and authorized. Boy, from a security perspective, we don't do a lot of this right now in general. You get on your laptop, you authenticate to your infrastructure, single sign-on, you have at it. Single sign-on is sort of the anti-zero trust. So this, if you love that kind of environment, when you move into a zero trust, everything is explicit each and every time you use it, and depending on how far they want to take it. And the government is trying to eat its own dog food on this, and it's definitely fascinating to listen to some of the users who are having to survive in these environments, all right? Okay, so policies are dynamic and calculated, and from as many data sources as possible. And you'll see that there's these enforcement engines that typically get deployed. Okay, so zero trust assumes compromise. And so the left is kind of today. So you've got these little sort of stars, if you will. This is a geek's version of graphics, right? So you see in the big purple circle these basically clusters of solutions. So today, there's pretty much once you're inside, we like inside. But if there's a compromise from the outside to the inside, then all of those systems are basically exposed. And we're seeing that in the case of ransomware attacks, where the bad guys get in, they will do reconnaissance for an extended period of time, identify all the systems, look for the backup solutions, take out as much of this infrastructure as possible. And part of the reason that's relatively straightforward to do is because of this inside-outside sort of trust mentality. In the case of zero trust, the trust relationships are at a much more confined level. So your email has its own trust relationships of the systems there and nothing else. And so the dynamics between, for example, if you've got like Exchange and an Active Directory, Active Directory might not just be accepted as infrastructure. It may need to be authenticated access. And changes to the Active Directory have to be handled in different ways to sort of fit into the zero trust. I'm just picking on Active Directory. It could be LDAP, for something in the Linux or Unix kind of environment. But really, what we're looking at here is you're trying to minimize the damage from a compromise. So if one goes down, not everything could potentially go. So compartmentalization is really sort of the mantra. And then the level that compartmentalization is where the fun is. All right, so complete compartmentalization, say that 3 times, is not very useful. So zero trust tries to apply specific kinds of policies continuously. Let's see if I can get down this list. All right, so you'll hear things like least privilege. So that requires knowing all the subjects. Least functionality requires knowing all the objects. Least accessibility requires knowing access needs. Least exposure requires accessing device services. Platform integrity. Coherence, basically knowing intended, expected, observed behaviors. So the security community over time has found it actually is a bit easier to profile expected known behavior as opposed to trying to block everything that's bad. And if you think about firewalls, they typically try to block everything bad, so the rule sets get increasingly complex. With the use of things like machine learning and artificial intelligence, it's becoming a lot easier to profile what a particular organization, how it uses its IT resources. So something like artificial intelligence is a tool that we see the zero trust community is definitely going to be leveraging. So then you're dealing with anomalies. So Billy Bob Joe is off accessing this website that he doesn't really normally access, and maybe he's paying his bills. That might actually get flagged in a zero trust environment where other times it wouldn't even be visible. Okay, so what does achieving zero trust mean? It means device trust, network trust, workload trust, user identity trust, data trust, And the problem is not every product is designed to work together. And this is part of the complexity that our friends in the U.S. government are definitely experiencing. Is they want to deal with all these sort of trust scenarios, and the products that they're depending on don't necessarily play well together, at least at this stage. So if you're a vendor interacting with the U.S. government and you're hearing the word zero trust, these are the kind of things that they're looking for. And if you don't have a good answer to how you deal with this stuff, then you'll probably get quality time with them in terms of, well, this is what we'd like to see you do in the future. Okay, so this is a high-level architecture that NIST was asked to basically develop. And I guess the thing that really is important to pay attention to is where you see that blue circle-ish kind of thing, this policy enforcement point. So and this is the piece that's different in zero trust than sort of your traditional sort of security infrastructure. So a firewall is kind of like an enforcement point. So you put all these rules in, and then you have some sort of sweeper rule that says, you know, if I don't explicitly let you in, I deny access, or maybe you default to, well, if I can't flag you as a bad guy, I'll let you come in. You know, but there's, you know, that's often the policy enforcement point in many organizations. What this is about is all of your infrastructure, your services, your data access, all those things are interacting with a policy enforcement point. And a decision as to grant you access, let you use that service, is being driven completely by this policy enforcement point. So that means you've got to define all of those policies. You've got to know all of those users. So this is back to having to fully understand your infrastructure. That's a pretty high bar for a large organization to basically sort of step up and deal with. So what we're seeing is basically a transition to this kind of model, picking strategic aspects of your infrastructure and moving that particular piece into sort of a zero trust architecture, and then sort of building out from there. So this is back to those little cul-de-sacs, if you will. So it's not a one and done for everything you're doing, or you could end up spending millions of dollars to, assuming you could buy all the pieces, to move to this kind of model. But it's really at the heart and soul is how do you establish these policies? How do you collect all the information you need to be able to basically deal with this? So if you're thinking about zero trust, anybody think about zero trust? Okay, so this is one of the critical pieces of how are you going to do this, and how are you going to load it with the details that you need to operate under. And it's not a trivial kind of undertaking. So everything we're seeing so far is to not try to swallow the whole elephant at once, just take a small piece, probably one of your more critical pieces, and try and apply, zero trust architecture to it. Okay, why does this matter? Well, I kind of hinted at it. There's a U.S. executive order from President Biden came out. It definitely lit a fire under NIST and CISA and other elements of the U.S. government. I was on a call earlier this week with CTO of CISA, which worries about protecting the U.S. government kinds of activities, and maybe the rest of the U.S. And they're focusing on some of the network pieces of this. So they're trying to figure out how to deal with the network aspects of zero trust, and a small number of systems, as kind of their starting point. And if you go and look at some of the system materials, you'll see that they've got quite a bit of documents that are out now in terms of how to go about doing this. it's very much a work in progress, and the early feedback is this transition is not cheap. It's fairly expensive kind of model. The hope, though, is that it will significantly reduce the attack surface, for government entities. And there's a lot of interest in seeing if critical infrastructure can be covered this. And that's significant because in the U.S., about 90% of critical infrastructure is not in the hands of the U.S. government. It's in the hands of private sector. So there are a lot of organizations that are doing critical infrastructure as identified by the U.S. government, who are paying attention to this because they recognize that they may have to deal with it. So as a vendor, if you're a supplier to the U.S. government or potentially operating in critical infrastructure, you're very likely to be confronted with this, assuming it's not abandoned, and I'm not seeing any indication that anybody's throwing their hands up in the air yet on it. So, there are lots of concerns about how to deal with supply chain issues. You've probably heard that several times, in security talks this week. Insider threats are a big concern. And it's, from a U.S. government perspective, it's almost assumed that major suppliers have elements of nation states and organized crime embedded. And again, so they're looking for how to not have massive solution that's all part of one free love kind of scenario. It's more of a how do we minimize the damage from insiders who may already be embedded. From a developer standpoint, to deal with zero trust, you're going to have to change your processes to basically deal with system security engineering practices. And this concept of zero trust ready. Now, if you were here earlier when I was talking about certification programs, this is a hint of there may need to be some sort of evaluation or criteria that a product has to undergo. Is it a formal, like FIPS 140 or common criteria? It's not clear at the moment, but there's definitely an interest in, is this product, can it fit in a zero trust ecosystem? And today, I don't know that we could actually tell you explicitly, well, that would mean you have this and this and this and this. But I can tell you that if you don't know how to work with a policy enforcement point, if that concept is not in your vocabulary, you are not zero trust ready. But I can't tell you which policy enforcement point you need to be able to talk to. So this is part of the challenge that we are kind of staring at right now. Okay, so when Thomas and I were talking about this session, we were trying to figure out what could we share with you from a storage perspective, because most of the materials that are out right now, storage is sort of far enough down the stack, so to speak, that, and a lot of the focus is on the networking aspect of it. There's not a whole lot of material that's been developed on this. And so based on some conversation he and I have had, plus some crosstalk with CISA and some other players, we thought we would offer some ideas for what you might want to think about from a storage perspective. So the concept of compartmentalization, this is sort of heart and soul of zero trust. So, but to what level do you need to take this? If you're thinking about if you develop storage arrays, for example, is it at the storage array level, or do you go down to the drive level, or maybe even lower than that? So like in the case of computational storage. You know, this is one of the things in the back of my mind when we've been talking about some of the security considerations for computational storage. It might need to be able to defend itself, you know, as a storage device or a computational storage processor might need to be able to establish explicit trust relationships and participate in its own protection if it's going to be an element, you know, an identified element in zero trust. It could be at a much higher level. So it could be, you know, a NAS filer, you know, as I said, could be a block-based storage array, could be, you know, a variety of things. But at some point, storage is going to be looked at and considered a compartmentalized piece. So anything that it's interacting with, it's going to need to establish explicit trust relationships, and this policy enforcement engine is going to be a party to that. We don't really do a whole lot of that today. Maybe with the management interface, but not the data access. Yeah. So to attempt to repeat the sort of the question is how do we determine what's the right level of compartmentalization, or an acceptable level of compartmentalization? My observation to this point is that's very much an open question. And even watching what organizations like CISA are doing, they're struggling with that as well. And part of the reason they've actually started with the networking piece of it, because they've realized that that's essentially the front door to all of their systems. So, and that they are multiple doors. And so they're trying to determine how to differentiate, you know, if you come in this particular route versus this route from a networking perspective, you know, how to differentiate that, how to control the users that are on their networks. They're just now getting into looking at sort of the system breakdown. Now that said, when you look at from an industry perspective, there are significant efforts underway to deal with platform security issues. So some of the things that you highlighted, we are seeing movement to try and deal with this. Things like attestation and measurements for various components. OCP is an organization that's touching on some of this, where at least from a platform perspective, as the system is coming online, the various components are basically saying, "Hey, I'm an SSD, and I'm reporting I'm in this state," and you know the server is going, "Oh, yeah, that's what I'm expecting," and if it's not, then it takes some sort of action. So we are kind of seeing from an industry perspective efforts to deal with sort of this platform level. But in some cases, we're actually seeing, and I mentioned not to single out computational storage, but it's an interesting one where it may have enough capability where it can actually defend itself. It can recognize whether it's under attack, and this may be important when you talk about things like ransomware. Is can you, as part of the platform structure, recognize when an attack has been initiated and defend yourself? So recognition is nice, but can you somehow prevent the attack from, once it's detected, from going any further? Or maybe you're nailed, but you tell your neighbor, "I've been nailed. Take this action," kind of thing. So I think we're going to see inside of a platform those kind of activities. That does fit into a zero trust kind of environment. How far they take it down, very much an open question. It's part of the reason for bringing this in and sharing with you that it's not clear to the detail of it. It is clear, however, systems like email and at that level, databases, those are naturals in terms of you're going to want to compartmentalize those and not just let anything get at those without explicit trust. Very much a work in progress though, and frankly, this is a non-trivial bit of implementation. I had my first taste of it probably 4 or 5 years ago, where we used some of the Cloud Security Alliance's software-defined perimeter, which is a way of dealing with zero trust, and combined that with some biometric information, biometric authentication to use with ATMs in Japan. And the amount of effort that was required to just get the software-defined perimeter piece in place, which actually has that policy enforcement point, that's really what we were integrating, took quite a bit of effort to kind of get that embedded. And in the end, the customer was like, "Oh, can't do this." So mm-hmm. Well, I'm not sure I can characterize the question, but I think what it's forcing organizations that are pursuing zero trust to think about is just that. It's inside outside is not at the organizational level. It's not in the office. It's inside outside is really kind of at the solution level, and so that's a rethinking of so what's the appropriate boundary under at which I'm going to establish basically this kind of stuff. So it may not make sense, for example, in the case of computational storage, because you may not be able to put in place policy enforcement point. Maybe, but where does that exist? How does it interop? How does it engage? And if it doesn't make sense for a PEP, then that's going to give you some hints as to whether it's appropriate or not. And that's and again, that's kind of why I came back to this architectural diagram. Now, from a developer perspective, if you're thinking you're going to have to deal with this, if you know that you've got to basically interact with this policy enforcement point, what does that mean from a product standpoint? I mean, identities and authorization and access control. Those are. I mean, that's what this is talking about. It's basically saying you can do this, you can't do this, and it's real time or near real time, right? So you're engaging something, or it's engaging you, depending on how it's implemented. But from a product perspective, how does your product fit into an ecosystem that you've got somebody looking over your shoulder, and you're doing, "Mother, may I?" And he goes, "Yes." "Mother, may I?" "No." So how do you do this? How do you do this fast? This may force you to redesign your product to be able to deal with those kind of decisions. And where it gets interesting is the concept of time. So Billy Bob Joe works Monday through Friday, 9 to 5. Policy enforcement point might actually know that. And the value added is the system that's asking "Mother, may I?" It doesn't necessarily know that Billy Bob Joe is only really allowed to do anything between Monday and Friday, 9 to 5. Okay? But the policy enforcement point knows that. And so when Billy Bob Joe is in trying to do something, if he gets into work a little too early or runs a little too late, he might actually have a problem. But your system, the product that's using this, gets the benefit of the policy enforcement point. It knows what this person is allowed to do. Where it gets really interesting is when you move from the human to system kinds of decisions. Is the database engine allowed to access this, or is something else allowed to access the database engine? That's also fair game in zero trust. So you can. But the core from a product perspective is, how would you engage something like this? What would you need to get from the policy enforcement engine? What would you need to be able to provide to the policy enforcement engine to be able to sort of fit in this environment? I mean, just to sort of boil it down to, as a starting point, it's how do you engage this is really sort of core. Because if you can't do this, you're really not operating in a zero trust architecture. And you're kind of transitioning to it. So this is one of the fundamental kind of concepts here. Well, yeah, this is definitely an area of discussion. So in the case, so the question is, will we be seeing standards on this? The IEEE working group that's dealing with zero trust security is currently working on a guidance standard that is looking across there's multiple zero trust architectures, not just the NIST one. There's multiple architectures, looking across those and trying to formulate some guidance. So, for example, the guidance I just gave you is you need to be considering, how to engage or leverage or utilize or communicate with a policy enforcement point. That's sort of a core concept that you're going to have to be able to deal with. So it's looking at some of those activities. Now, the reason that work is intriguing is it's intended to actually go to ISO. So it's being developed by IEEE, and it's a document that'll have some number of should, probably no shalls. And the intention is to float it up so it would become an ISO IEC IEEE standard. This would be the first international zero trust document, at least as things stand today. We do not know whether the international community is going to be willing to accept it. This is currently a US phenomenon. And we don't, this is really going to sort of test the waters in terms of how useful it is. One of the things that this activity is looking at is the new 27002 standard, which talks about the security controls. It's a extensive control set. One of the changes, they added attributes. So if you're familiar with the cybersecurity framework and detect and prevent and all these kinds of things, or traditional confidentiality, integrity, availability kinds of labels. They've identified a set of different kinds of attributes. And we're now looking to see if there's something that could be done from a zero trust perspective. So if you look at all these security controls, how do they potentially fit into a zero trust kind of framework? That's very, very preliminary work. We're probably 2 years out on some of that. So you're most likely going to see developments coming in from NIST and CISA in terms of their needs. What do they want to buy from vendors? So if you're sort of having to confront this environment, then you're most likely going to see early materials there. But it's very much a work in progress right now. Oh, I don't know if that's helpful, but this session is intended to, when we kind of look out on the event horizon, we see this train sitting in the yard kind of going, we're not quite sure where this one's going to go, but we do know that this could be extremely disruptive for certain kinds of products. Low-level devices, maybe not so much, but you get up to like storage arrays and whatnot. Definitely, if you think about this from a hyperscaler perspective, they might actually have to containerize, elements of their infrastructure just to support, for example, a cloud environment.
One thing I've been thinking about as we talk about this is SSDs are basically a confluence of interfaces, which is getting much, much worse with time. I have at least 3 different ways to get to a management interface. I'm now adding memory and other ways to get to computational storage. I have all these things. As a device manufacturer, I'm confused now whether I look at each of these different worlds as zero trust and a network I don't trust, or whether I should be a castle with a moat.
So I guess the way I would offer is the fact that you're now thinking about that is a good thing, because once this sort of pops into your head, you now kind of look at the world a little differently. You're like, well, and especially if we're writing specifications, which I think there's probably a fair number of us here at this event who are involved in a variety of, now you're thinking about, well, do we really want to have all of those interfaces? Because now we got to secure all those potentially. And what does that mean? And how do we do that? So the idea here is this is not going to be an instantaneous kind of change. It's going to take a lot of vendors working on a lot of different products and collaborating with government customers in terms of what they're ultimately going to need. And we see right now every indication of they're like, damn the torpedoes, and this is the direction that they're going. I mean, there are conversations happening with Congress trying to figure out how to force this down to deal with things like critical infrastructure. So these are the kind of things when I hang out with different lawyers and whatnot, I'm watching for, is this being codified into regulations? Is this being codified into law? Is this part of budgets for certain agencies? That shows the commitment level, if you will. When Congress starts funding stuff like this, then it's starting to get pretty serious. I'm having worked for NASA for a significant amount of time as one of the civilian agencies, I'm not seeing a lot of traction inside of NASA yet on zero trust, but all the security communities, I am definitely seeing discussion and chatter around zero trust. So, but it is important from a sort of mental exercise thinking about this. It is healthy to think about, well, if I had to defend myself as a product, how would I do that? And in some cases, products have never had to go through that kind of lines. It's basically back looking at the risk factor. This is just how do you deal with some of those risks? And I know we kind of gone off the rails here, but really this is more important to kind of let you know what's in the works here. I think we pretty much dealt with this. This picture is just sort of pictorially, today, maybe tomorrow, and we were struggling with how to the sort of the kindergarten view of what does zero trust look like. You could actually have these policy enforcement points might actually be talking with each other, or they might be standalone, might be isolated. When you layer in things like cloud and multi-cloud and federated cloud, these policy enforcement engines get even more complex. So the hyperscalers, if they're forced to deal with this, this is going to be there's going to be some interesting challenges. Okay, so there's a bunch of references here if you want to go off and see those. And I think this is a journey, not a destination. There are multiple architectures. Tread carefully. You can spend a lot of money. You're definitely looking at life cycle. And vendor interoperability is going to be a huge issue for this to be successful for the U.S. government and internationally. And storage is still a TBD, but those of us in the storage, at least storage security, we're trying to figure out how to help this community, understand what you might have to do. Okay. Please take a moment to rate this session. Hopefully this was helpful to you. This is more of a kind of a heads up or duck under the table. I don't know which one you choose. With hair on fire, yes. Okay, thank you.